In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos. Each note, a shot of pure ether, struck the Einsteinian demons, dispelling them back into the void. The world was saved, not by a warrior, but by a musician, a scientist, a man with a flute. Remember, in this universe of wonder and mystery, sometimes the most unlikely heroes make the biggest impact. Keep your mind open, your heart brave, and who knows, you might just find the ether within yourself. So here's to Dayton Miller, the flute ether master. His melody still resonates, a testament to the power of harmony in a chaotic world. In a world where space and time are intertwined, one man dared to challenge.
All right, hello and welcome to Ether Cosmology Roundtable number 82. Tonight we're going to be doing a presentation on a tribute to the Scandalous clocks, and that's in reference to a paper written by Ron Hatch discussing the noon-midnight problem regarding atomic clocks and GPS, which we'll get into as we continue the Prezi. But right before we get into that, a quick announcement to make. At 9, there's going to be a short intermission where we will discuss the launch of the Ether Cosmology merch, where to get it, where to buy it, what discounts are available, and how to get discounts, etc. So we'll go over that at 9. The Prezi should be about an hour. So here we go. So a tribute to the Scandalous clocks. All right, so before we begin here, we're going to discuss the special theory of relativity. We're going to open up our holy text. We're going to see what Einstein has to say, because modern technology is supposedly based on the correctness of the of relativity theory. And without this theory, GPS wouldn't work, and other descriptions of things like muons, etc., wouldn't work. But primarily, right, we're looking at relativity in applicable technology such as GPS. So we got relative motion, and we have the speed of light, and we have a cohesive timeline that has to be synchronized to. So this is all a recipe for everything that requires the special theory of relativity. So we're going to use this as our guidebook to figure out what the mainstream interpretation of how an atomic clock is supposed to function under the paradigm of relativity theory and what that exactly means. So we'll start off with the Steelman, and then we'll get into Ron's paper, where he talks about the issues in not only GPS, but with the very long baseline interferometer, which is a network of radio interferometers that are set up that monitor radiation from quasars that are sending radiation at us at a specific frequency. And throughout the year, there is a variance that's measured from two places that are equidistant from one another that is implying a C plus or minus V measurement. So be sure to stay tuned for that, because that sounds dangerous. And surprise, when we find out what time of year this fluctuation happens, you might recall that a certain Mr. Miller and his interferometer was measuring a similar periodicity shift that corresponded to not only sidereal time, but annual solar time. All right, so on the electrodynamics of moving bodies by Einstein, 1905. So of course he starts off with his postulates, which starts from a conjecture, and his conjecture and postulates stem from relative motion of a magnet and a conductor and a piece of copper. And then on top of that, all experiments trying to measure the velocity of Earth through the cosmos came up with a null result. In other words, they weren't able to falsify the premise that the Earth was stationary. So they started coming up with a philosophical, and they started merging physics with their cosmological belief that the Earth was in motion. So to do this, they had to make an absolute rest system, a static ether that everything traverses the cosmos through, and all motion would be relative to that. And that's how they were conceptualizing it. So Einstein had to come. So after all those experiments where they were, failed to falsify that null, Einstein comes through and he's like, okay, so in my theory, all inertial frames are equally valid. So if you're in an inertial frame, if you're moving at a uniform constant velocity, then you can't use the speed of light to measure a difference. That's the first postulate. So they're because they're all equivalent, and because of that, you're not going to be able to tell any differences. And then in addition to that, he says that the speed of light is propagated in empty space with a definite velocity that's independent of the state of motion of the source or the observer. And that's important because with that ties into the first postulate in using light to tell a difference to be able to differentiate between the reference frames. So the equivalence of the reference frames and the constancy of speed of c are tied into one another to start the theory off. And he goes on to eliminate the luminiferous ether as a product of mathematical usage, where we have this fictitious reference point that all motion is relative to that we're going to use, or an actual fluid medium or anything like that. He's removing them both mechanistically. And he goes on to say that, he's not going to assign velocity vectors to a point in empty space where electromagnetic processes took place. This is really important when it gets into the Sagnac effect and how we interpret these experiments and GPS in regards to relative motion, and how the theory is supposed to interpret measurements between source and observer with respect to the inertiality of their frame, right? All right, so diving into the theory a little bit, we get into the kinematical part. It says here, so section 1.1, we have the definition of simultaneity. So Einstein gives the example here that simultaneity has no meaning because time is defined locally between observers. There's no absolute time, like in Newtonian or the classical physics. There's no absoluteness. Time and space are relative. They're functions of your velocity, and and that velocity between whatever else is in relative motion to you. And the fact that there is no background, the fact that there is no ether medium or anything like that, we're not going to use that as a reference point mathematically to describe motion or velocity or changes therein. It'll all be done through the source and the receiver, instead of using a fictitious point for it, a fictitious midpoint for it to be relative to. And then time. So by redefining time in that way, what he's doing is he gives the analogy of, suppose, a train shows up at my location every day at 7 p.m. Well, if you're in a different time zone, is that 7 p.m. the same for you? Well, no, you're in a different time. So 7 p.m. only means something if you're in the same time zone as Einstein, right? So if you were to look at it in that regards, time isn't this unified structure that would apply uniformly to someone who's, not in the same time zone as Einstein, so to speak. Everyone has their own time. And this changes the meaning of simultaneity. And we'll read a little bit here after the analogy. He goes on to say, and in fact, such a definition is satisfactory when we are concerned with defining time exclusively for the place where the watch is located, but it is no longer satisfactory when we have to connect time in a series of events occurring at different places, or what comes to the same thing, to evaluate the times of events occurring at places remote from the watch. So this ties into redefining simultaneity, because simultaneity was previously understood as absolute. So when he gets into the train analogy, if you guys have ever heard that, which we've talked about here a lot on here, but the train analogy would be, we have a moving train and we have a stationary observer. When the midpoint of the train intersects with that stationary observer, suppose two lightning strikes occur that are on the opposite ends of the train. What will the observer on the train see versus what will the observer on the ground see? And is that event truly simultaneous in both frames, or is it physically different, right? So in classical The classical understanding would be obviously the event is truly simultaneous for both people, but the moving observer is going to perceive it differently because there's going to be Doppler shift for his motion. He's going to perceive that the one that he's moving towards happened first, right? But that's an apparent effect. It's not physically different. Now, Einstein, what he puts forward is that it's actually physically different and would lead to physically different outcomes. As part of his theory for simultaneity. And this is a huge a huge divergence from the classical thinking, right? Because we're talking physically different outcomes now that, simultaneity has no meaning. That's pretty crazy. So that's pretty groundbreaking. So we're going to go on to continue here to see how he's going to supplement this claim, because that's pretty big to say that. So here he goes on to give the analogy using relative motion and a midpoint for that motion. So if you do an analysis here on this clock scenario that he gives for A to B, what you'll find is that if you use the speed of light as a constant starting from the midpoint, you can describe the traverse time to be equivalent. But if you take it from the reference frame of A and then going to B, you're going to have a different time. It's not going to measure the same. So he's setting up here. Remember how he starts off by saying, we're not going to use any fictitious midpoints or anything like that, right? We're not going to invoke something where the observer isn't. But what he is going to do is, on the back of this postulate of the constancy of C, in order for this to work out, the one-way speed of light has to be a constant as well. And that's never, quote unquote, by the mainstream. That's never been measured. It's highly contested. There's measurements of it, but there's not measurements of it if they go the wrong way, et cetera, which we can get into at the end here. But the fundamental backbone of this is that he's going to take a symmetrical midpoint of any distance between these two observers in relative motion to one another, and then the speed of light that traverses that is going to be constant to them. But what he goes on to show is that, what he goes on to show here is that the because of those distance changes, if you were to take it from the reference point of A or B, doing that with the speed of light, you're going to be left over. You're going to have a difference. You're going to have a deviation. And what he turns into that deviation is link contraction and time dilation. But so this is the baseline of what he's setting up for here. So I'll read off a couple of these real quick. So he's got local time defined by a function of relative velocity between two systems, K and K prime, that have local time coordinates that are independent of any other coordinate system. So if you did J and J prime, those times wouldn't be the same, right? Because that would be implying absolute time. So that each time is independent between your two relative observers. Without absolute simultaneity, although the time in K and K prime is localized, K and K prime are independent relative times to each other. So even though those lads are, even though we have a system where we're describing A and B and their relative motion to one another, their times are not the same, right? The one that's being stationary, the one that is absorbing the arbitrary midpoint that's invoked for the constancy of C to traverse both ends of the, to go to A to B for it to be symmetrical, right? That time is being given to the stationary observer, the one that's being treated as stationary. So that's actually a really interesting mathematical trick, because, we're not going to use a midpoint, but you're using the speed of light in an inertial frame, so to speak, as your midpoint for your coordinate time. And then you're making all your deviations relative to that. So, it's very sneaky, but it's still kind of doing the same thing. And that's why it was consistent with Lorentz's Aether theory, right? Because it's the mathematical framework is the exact same. It's just Lorentz had a physical mechanism for the compression and dilation of time, or the compression of length and dilation of time was that it was, rigid bodies, so-called rigid, were moving through an ether, and that was causing a compression, was facilitating the compression mechanism. Now, Einstein, using the same framework, is like, hey, there's no ether, but just the relative velocity distorts time and space. And that sounds retarded, but you can mathematically show that in a sense. And then if you want to tell the story of how you're interpreting that, that deviation in the coordinate system that you're defining, as length contraction and time dilation, then, you're good to do that. So by splitting the midpoint of the traverse time, Einstein defines the one-way speed of light to be c by assuming a symmetric round trip for the time and equidistant reflection. This is a convention, not a measurement. This is extremely important because, like I said before, this was claimed to be, experimentally measured / not measured. This was just asserted by function of what this would have to be mathematically to work out. From that, he concludes that the relative times to A and B measured relative to the stationary midpoint at T prime, which is what he starts, I'm not going to use any fictitious midpoint. All right, dude. But, relative to this fictitious midpoint, that would be equal. And then based on that postulate, the speed of light would traverse circuit, and it would be the same in both directions, irrespective of the motion. But you would be left over with a little difference based if you were to take the reference frame of the of A, looking at B instead of the midpoint, and then that's what he turns into length contraction and time dilation. So if B tried to reference A's clock while B is stationary and he's looking at A moving, well, there's going to be a difference there. And depending on if they're moving towards or away from one another, that's going to dictate that difference. We define simultaneity in such a way that light divides time between events symmetrically so that it has a nice round trip. So remember his thought experiment with the train, with the midpoint. It's all about the midpoint and light traveling at the same speed in both directions, blah, blah, blah. It's always about the midpoint to establish symmetry, right? Because it's space-time symmetry. This is the fundamentals of what's called Lorentz symmetry. Earlier I said that Einstein's, this theory's framework is based on Lorentz's ether theory, the same mathematical framework. So the same framework, it's all tied into the same conceptualization of space-time and how to satisfy the conditions of a successful transformation is to have the speed of light be referenceable to this midpoint between the two observers, which requires space and time to be symmetrically contracted and dilated in the moving frame together. You can't have one and not the other in the frame. All right. So by this rule, clocks moving in the frame appear to be desynchronized from the stationary frame, and this in spatial intervals appear to be contracted. If you didn't do this, then the speed of light would be asymmetric. It would be c plus or minus v. So instead of c plus or minus v with respect to a background or a fictitious midpoint or whatever, right? He's changing the coordinate system to fit to keep the speed of light the same. All right. So then he gets on to the theory of transformations of coordinates times of a stationary from another system to one in uniform motion relative to the former. So what we see here is the end of his conclusion after he goes through his derivation here is that coordinates should be transformed using Lorentz transformation, should be using this. So the change in time is going to be a function of the square of the velocity, and same for distance. And then beta here is going to be 1 over the square of 1 minus v squared over c squared. And this is just giving us a really, really, really tiny ratio here of the speed of light. So again, this wasn't empirically observed or measured. Nobody did this and realized this. This was asserted as a mathematical consequence of the constancy of speed of light and how the coordinate systems that describe the relative motion using that would have to change to satisfy to make it mathematically work out. So that's extremely important to understand that this wasn't like somebody has measured length contraction or time dilation, because a lot of times you'll hear that there's measurements of time dilation. You've never heard of one of length contraction, though. Well, remember, space-time symmetry, space-time, right? It's not hyphenated. It's not two words. They made it space-time, symmetrical. They're linked. They're intertwined. So anytime you hear time dilation has been verified, well, you should look for the relativistic length contraction changes, and no one ever talks about those. No one speaks about that. But it's an important aspect of it. But we can get into that with the muon, and we have in other prezis, because they talk about the muon being the proof of time dilation in addition to atomic clocks, but it turns out to be an asymmetrical use of space-time symmetry. Space-time symmetry can't be symmetrical if they're only doing a transformation on the time coordinate. All right, so the asymmetry arises from defining the simultaneity by a round trip of light at the midpoint and not from a physical difference of the clocks and rods. So earlier we talked about the mathematical consequence of this, and it's not something that somebody measured, but it's just the mathematical consequence of this. All right, and then in section 3, he goes on to talk about link contraction and time dilation, which we'll get into. All right, and then this mathematical treatment here, like I said earlier, this is called the Lorentz transformation, changing these coordinates by a function of beta, which is otherwise known as gamma, which is going to be your ratio for link contraction and time dilation. That's how much your coordinates are going to change with respect to time and space as a function of their velocity. All right. Okay, so he gets into the physical meaning now. So how do we interpret this physically? We just got handed some mathematical consequences. How do we interpret this now? So he goes on to give the analogy of a rigid sphere moving relative to a stationary sphere. And that sphere experiences link contraction and time dilation in the direction of motion. And it's actually relative to the stationary sphere, it looks like an ellipse now, because it's link contracted and time dilation. Its rigid structure is now unrigid, and now it's an ellipse. All right, so and he goes over the transformations for that, and he ends up with an analogy here that says, oh yeah, so in his, he starts off with, he primarily talks about how it changes it into an ellipse, the shape because of the contraction. But this also applies to time as well. So he gives the coordinate here for what happens for time. So I just wanted to point that out for the symmetry purposes, because that's important to understand what that it's symmetrical for a reason. So a clock move from A to B in the stationary frame will no longer be synchronized with a clock that has remained at rest, lagging behind by 1/2 times time times velocity squared over c squared. And this is a really important part that he adds in here, because this is going to be how he gives an explanation to how you're going to interpret things like GPS in regards to satellites moving around the Earth, or interferometers where you have a stationary, or where you have an emitter in a recorder moving relative to, or in uniform motion. This is going to be how this is described. So in addition to all this, for the physical the physical meaning of the equations, not the kinematic, blah blah blah, right? What's an accelerator? Is acceleration an inertial frame? Is blah, 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 like, right? Okay. Physical meaning of this: if it's moving at a uniform constant speed in any closed polygonal loop or any closed circuit where the points A and B coincide, then these equations apply. And it's also valid for any continuously curved line, which is extremely important to what Sagnac did in 1913 in understanding why and how his configuration of his apparatus falsified relativity theory. This is the physical meaning of these equations, right? If the physical meaning of these equations is true, then a Sagnac interferometer predicts no fringe. Then if you're standing in the lab frame looking at that interferometer, you shouldn't see the fringe either. If you have a configuration where the source and detector are fixed to the lab and they reflect off 45-degree angled mirrors that are rotating, there should be no time difference, yet one is measured every time. It can only be explained mathematically by invoking a fictitious midpoint and dropping all of these second-order terms that contract on like the smallest possible scale you could ever imagine. All right, so he gives the coefficient of how slow a clock would be if it completes a circuit around the equator relative to a stationary clock at the equator. And that's going to be your 1/2 times time times velocity squared over c squared. So remember, he generalized the path, polygon or curved, so long as it's closed and completed at a constant velocity. Very straightforward and in plain English. very logically consistent.
What if measurements become inconvenient?
Exactly. Duplicated this slide. Right. Then he goes on to talk about velocity composition. So in the classic theory, right, if everything's relative to some fictitious or real background, we could do c plus or minus v and get the same result. But that would change the speed of light. That would mean the speed of light is being measured as being faster or slower as the function of velocity, whether it be to the first or second order. And that would, make the speed of light not constant then, right? The speed of light has to be constant. This is the big change in his theory from classic physics, because everyone knows, like if you use sound, for example, the speed of sound would be measured relative to its medium for one, but then relative to the velocity of the observer making the measurement. So that's, Doppler shift, for example, right? Like that mechanism would lead you to the conclusion that you're measuring sound plus or minus your velocity, right? But Einstein's saying here that you're going to measure c plus or minus nothing. It's going to be, and that's going to equal c always. I'm sorry, he's saying you're going to measure c plus or minus v, and it's going to come out c. And he does this by adding this term at the bottom here for the denominator, 1 plus the velocity over c. This is basically ensuring that whatever you add to this, it's never going to exceed the speed of light. It's always going to come out to be the speed of light. So he's treated this such that if you apply his equations and his velocity composition to, I don't know, a Sagnac interferometer, for example, where you have a emitter and a detector, and they're both fixed on the platform, and they're rotating at a constant speed, so there's no relative motion between them, right? You could add and subtract the clockwise and counterclockwise velocity and determine that there's no change in the speed of light. Yet, to the first order, Sagnac has measured exactly that. What do we do here, guys? We never talk about this again and just invoke fictitious midpoints and do transformations from them, or from that fictitious midpoint, to describe first order effects. We no longer talk about velocity composition in this way. All right, so if any of this was true, go ahead. Do you have a question?
So we can only use important midpoints while proclaiming that we don't use them at the same time. Of course.
Naturally. So if any of this theory is true, in modern times, an atomic clock should be synchronized in the following process. We should have a stationary clock that's ticking away. Well, first of all, to start off, the synchronization for the first clock on the ground here, right? What we're going to do is we're going to send a signal from A to B, and we're going to set it with an offset to subtract the timing difference that it takes to traverse half of this. And then from that, it's going to hit this and come back, and then it'll be in sync. Once this clock has been synchronized, right, the moving clock is going to move past it, and at the time that it intersects, it's going to do the exact same process. So we'll go through the cycle here. So we assume that the speed of light is c, and it's constant for both ways and in the one-way trip. It's super important that the one-way speed is asserted to be a constant, because remember, if you do a configuration like Michelson-Gale-Pearson or GPS measurements, for example, those are one-way trips. So we have a way to test, through timing, the one-way speed of light. But for all intents and purposes in the mainstream, they're ambiguous about it. They act like it's never been done. A couple times, there's a couple experiments that you can reference where they're like, well, here's where it did do it, but we had to cancel out seasonal and sidereal fluctuations, but we're good to go. So anyway, super ambiguous on that, but mathematically, right, it has to work. Like either way, it doesn't matter if it's true or not. For them, it has to be true. So 2, when the clock is moving, alpha it intersects with the stationary clock A signal is sent from beta encoding A's start time. Then the moving clock beta receives the signal and applies a half-time correction to account for the flight time in the clock, to traverse back and forth reference. And then number 4, the moving clock B and the stationary clock, the moving clock B beta, the moving clock B then synchronize their times with A using this signal to correct. Then at 5, any time difference between alpha and beta is then adjusted to match the stationary clock moving relative to alpha. No, the stationary clock and moving alpha, sorry. So either way they slice it, what they're going to end up doing is making sure this, like if the protocol fails for some reason, at the end of the day, based on the constancy of the speed of light, once they get this bad boy synchronized, they should be good to go, right? Because they've got satellites or whatever in an inertial frame, they say, because they're in free fall around the Earth. So once they get these clocks all set up, they should, they're not going to be able to reference any external reference frame for velocity change. They're going to be doing their own thing. They should be good to go. But what they're going to find experimentally, and this is a big part of Paul Marmay's paper, about the constancy of the speed of light, and A.G. Kelly's work, where he goes over atomic clock synchronization and GPS specifically, and the experiments that led up to realizing that Einstein synchronization is false and everything falls back on the classical equations, and it turns out to be the Sagnac equations that dictate clock synchronization. And the Sagnac effect is C plus or minus V on a one-way, right? So the relative motion of the clock with respect to something that the mainstream isn't willing to identify is causing the need for a velocity correction to be introduced into this clock so that it keeps time properly. All right, so this is what Ron Hatch has to say about the Scandalous clock situation. So this is from his paper. Before we get into the GPS aspect of it, we'll cover the very long baseline interferometer, which again is that radio network of interferometers that are synchronized via atomic clock. So a big thing with GPS and anything that uses atomic clock synchronization, your phone, VLBI, all these things, right? They're all synchronized to the same thing. So they're all on the same timeline. You can think of that timeline as an absolute timeline. Even if in mainstream they don't consider there to be an absolute timeline, GPS establishes an absolute timeline for all measurements to be relative to. That's how it derives distances based off of timing interval differences. That's how they derive distances, right? So, with respect to GPS time, so however they maintain that doesn't matter. It exists, and that's what they're using. So with respect to that, there's gonna we already found that they have to introduce clock corrections that imply that the speed of light is not isotropic the way that they assert in the mainstream here. So we'll read from the abstract. He says both the VLBI and GPS indicate that Earth-based clocks are biased as a function of their position and direction of Earth's orbital velocity. Now, a quick refresher on kinematics and dynamics. Mainstream paradigm asserts that heliocentrism is the correct interpretation of cosmology and physics, and that the Earth is moving around the sun, and that relative to the Earth's position throughout the year, clocks need to be adjusted. Well, the adjustments are not to the tune of Earth's orbital velocity, number one, and number two, the same could be said if the Earth is stationary and the bodies in the sky are in motion around us. That same position, so like with respect to annual solar time and sidereal time, these measurements can be, still apply just the exact same. But he's looking at it through the lens of the mainstream paradigm, right? Just to be clear on what that implies there. The evidence for these biases is discussed, and the result is confirmed by comparison of Earth-based clocks with millisecond pulsars. These clock biases, are precisely such that they cause the speed of light to appear as c in Earth's inertial frame. So there's a lot of yeah.
Does that mean specifically in the ECI?
Yes, specifically.
Wow. Okay, all right, this is great.
Yeah, so this shows that the speed of light is not isotropic on Earth's in the Earth frame, and that the Lorentz transformation is only an apparent transformation that results from the Solari inertial transformation combined with the clock biases. So, see here, Hatch talks about, he references the Solari transformation a couple times throughout this paper, and what this is this is just, it's the same as a Lorentz transformation, but it's acknowledging the fictitious, it's acknowledging the use of a fictitious midpoint. It's acknowledging that simultaneity is absolute. So it keeps the math. So it's basically, right? So check this out. We started with Lorentz's ether theory that assumes absolute simultaneity. It assumes a physical medium. It assumes that all motion is going to be relative to that medium, and has a framework where link time and distance are going to change as a function of the square of your velocity over c squared. That's going to make it look like you're in an inertial frame, right? Okay. And then Einstein comes along and he's like, hey, same framework, no medium, relative simultaneity, everything else stays. We can keep the changing distance and time, right? No medium and relative simultaneity. And then this guy, right, to rectify applicable technology and like the contradictions with GPS and relativity theory, Solari comes along and he's like, hey, if we just go back to the original thing, we're good to go, right? But they call it a Solari transformation. And it's just the same thing. It's not like a different thing. It's completely antithetic. But here's the important part, right? The use of this, the acknowledgement of absoluteness, the acknowledgement of absolute simultaneity is antithetical to relativity of simultaneity. It's antithetical to no absolute time. So they can't both be true, right? But mathematically, you need to do this to satisfy first order effects. So when something's directly proportional in the terms of velocity being, where the velocity of light is being measured with a variance plus or minus that's proportional to the velocity of the receiver, that needs to be able to be explained, because relativity theory is supposed to supersede the classic theory. If it can't explain classical effects, then it has no use, right? But when you apply relativity in the way that it's defined by Einstein to explain these things, you get a contradiction. So you've got some lads that realized the contradiction and came along and are trying to rectify it. So Solari and the boys get together and they're like, hey, forget about the old ether theory. Let's do a Solari transformation. That's the exact same thing. But we'll just that.
Yo, wait, so that sentence right there is like, so these clock biases are precisely such as to cause the speed of light to appear as c in Earth's inertial frame. That is so powerful. So the ECI frame, which we argue, in comparison with the ECEF, they had to invent, which literally removes the c plus v variant so that they can then proclaim that c is constant. That is the whole point of this whole coordinate system, and Ron Hatch knew it and said so right there. Hey, these biases are just making it appear as if the speed of light is constant in this special frame which we invented to show that the speed of light is constant. Like, whoa. Like, oh man, that's excellent. I don't think I've ever seen that before. And now I get the title of the presentation anyway.
Dude, it's insane, right? So we've got this whole mythology based on this magic box, right? That oscillates at a certain rate. 9,192,000,000 some odd times a second, right? And this provides, this is so accurate and blah, 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 right? But the whole mechanism like the whole atomic clock structure depends on an adjustment while it's in the while it's in the what would you call that? The chamber that it's mixing with the radio frequencies in the ionized, I'm sorry, in the emitted cesium, right, where they're mixing together to get the frequencies to match. Right, what they do is they introduce another magnetic field to make micro adjustments for variations that occur. So they have like an additional way to control these variances, like, and we don't know to the extent of like what they have to correct for and plug into these things to get them to work, right? But that's
Damn.
this is what we're led to believe after the device is working, right? They're like, look, the speed of light is constant after we made it constant by having it adjust for, latitude dependent corrections. And of course, their interpretation of this is that the Earth is a non-inertial frame, so the speed of light being not constant is a product of that non-inertial frame and trying to ascribe relativity to it, etc. That would be how they try to internalize it. So here's a quick screenshot of the VLBI station, or one of the stations. So this is a series of radio interferometers that are all synchronized to make one. In theory, right? What they're doing is, if you have a bunch of little catcher's mitts, but you put them all together, you make a big catcher's mitt. So they've got a big catcher's mitt. And they're catching into the sky, and they're seeing what they can catch. And what they're doing with this is they're measuring. They say that they're measuring radiation emissions from quasars, which are little dots in the sky that are sending out higher than expected based on their quote unquote assumed distance from us. The energy that they're outputting is disproportional. So they're like, what's going on here? So they have this whole lore on what a quasar is. What the mainstream calls a quasar is irrelevant, but what they measure in the sky is a little dot that's emitting a ton of energy. That's not and it's supposed to be super far away. So they need a way to describe why something could be that far, why something can be that far away and still emit that amount of it. And it's the reasoning is like it's a collapsed star situation or something.
If I may, I think it's a rather open-ended term that they get to conveniently use. Quasar is short for quasi-stellar object, and anything that appears stellar but does not completely appear stellar is automatically a quasar, because it's sort of like a star, right? I mean, it's a blanket term.
Oh, that's super ambiguous, dude. That's tight. So yeah, they got their ambiguous term. Whether or not it is what they say it is, irrelevant. They have measurements, and they're trying to just internalize what that is. So the job of this network is to look into the sky, get these radiation readings, and then they do their thing, right? So here's a configuration of what this looks like. So we got this big glove, right? So what they've done is they set up a network that would be such that where, based on the Terminator line, like half of the network can face the sky, the night sky, and make observations. So what they're going to do, what we're going to look at here, is kind of what it looks like. Here's another view of what it would look like here. So the sun would be on this side, Earth blocking sunlight, as they say, or whatever mechanism blocks the sunlight, right? So it's dark over here. We got our quasar emissions coming in. We got our interferometers reading the signals. And what they'll do is they'll take, because they're all synchronized to one another, they'll take differentials on the readings that they get and look for discrepancies and see, like, how long it takes for the signal from this one to hit here and here versus this one to hit here to here, that kind of thing, right? And what they ended up finding out is that, before we get to next page, what they ended up finding out, what Hatch points out here, is that on the winter solstice, there's a variance that's measured where the signal is received from the quasars 2 microseconds sooner than expected. And then on the delayed end, it's -2 seconds. Now, keep in mind, this is from the same wavefront, right? Because it's hitting the, it's an expanded out wave or whatever. They're supposed to be hitting these at the same time. These are equidistant apart from one another, right? But they're measuring this minimum maximum fluctuation on the winter solstice. That's what he points out with that. And what that means is that's essentially C plus, or that's not essentially, that's directly C plus or minus V. And the way that they try to interpret this as when the Earth is lined up with the direction of motion, and these two stations are orthogonal to the Earth, to the sun, I mean. Right, so I'll show you a little diagram of what that looks like here. So if we have two stations, I kind of offset this one so you can kind of see it. But let's say that we have a station here at the equator, then we have one directly behind it at the equator. They're going to be measuring. I put the sun in the wrong direction. It's hilarious. But anyway, they're measuring their signal here, right? And they're getting C plus or minus V. That's to kind of give you the visual of what's going on. So the sun is supposed to be on the opposite side here, and then these are going up and down, left or right of the sun. So they're orthogonal to the sun. They're getting their emission reading C plus or minus V, and they're interpreting that as, okay, this one must be moving towards the sun, and this one must be moving away from it, because they think that they're rotating as well as moving around the sun. But this is explained with a stationary Earth and a dynamic ether that has variance to it with respect to sidereal and annual solar time. The same exact mechanism would facilitate this, right? But this measurement comes out showing C plus or minus V with the same wavefront. And they're like, well, because we're in a non-inertial frame and the ball's rotating and the speed of light's constant, what's actually happening is relative to your position. You're seeing the wavefront as being slightly tilted. So it just looks like it's like leaning, basically the light is kind of like leaning in a little bit. It's just a little further what they're saying because of the motion of. All right, so let's look at was there about to be a question? I thought I heard someone say. Nope. All right.
Nope.
Okay. So here we're looking at the relativistic and Solari transformation here. Now, what he goes on to show here, and keep in mind, this is to answer a first order timing difference for GPS for clock synchronization. So this is to literally explain the Sagnac effect. We have a source detector that's going to be our reference atomic clock that's going to keep time, and then we have a moving atomic clock, right? And the moving atomic clock is out of sync with the stationary atomic clock, directly proportional to its velocity. So the clock is retarding by a function of its actual velocity, not by the square of its velocity over c squared, but by its v over c relationship. So what they show, let's see here, what Solari and the boys got together and showed was that because the way they have to explain this in relativity, right, is to invoke a fictitious midpoint, usually at the center of the Earth or something like that. So they'll hit up your boy ECI or ECEF and get in the center of that and make everything relative to that midpoint. But because again, it's a first order effect, so they got their midpoint, then they got their motion to the first order, and they're like, oh look, we can drop the gamma terms and it all works out. So anyway, what he shows here is that when you do a Solari transformation, aka do the same transformation that they do, but just acknowledge that you're using absoluteness, that they work out to be equivalent because you end up dropping the gamma term, and then it just becomes a function of that midpoint and the relative velocity to that midpoint. And this was that was mathematically confirmed by other relativists who were surprised and shocked that a theory of absolute simultaneity and absolute time and distance could make the same prediction as relativity theory. And it's like, yeah, shocking, huh? Or your theory is wrong. and and you have to drop all your relativistic terms to be compatible with the first. It's not.
Or
It's
you
not
could set them equal to 1. I mean,
it's
if you want
not,
to be sneaky.
dude, right? And they do, so it's not that shocking. Like their quote from the paper, they're word, but you can't believe it. Oh, really? Okay. So, and again, so these gammas cancel out, and what it ends up becoming is just v over c, right? Velocity and distance over c squared. Where does that look familiar? Delta t is equal to the change in velocity and distance over. Is that what? Hold on, wait a minute. Is that Ruyang Wong? Is that velocity and distance over c squared? Is that Sagnac down there? That's saggy. So all of this, right? All these transformations, all of that reduces back to the classical framework. And this is the correction that they use to synchronize atomic clocks for GPS. When they talk about, we launched this atomic clock and the GPS, blah, 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 right? Oh, we had to offset it, blah, 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 blah. You know what they're also doing? Routinely correcting for its velocity with respect to absolute space. So this correction causes the non-isotropic speed of light in the Earth frame to appear as if it's isotropic. A little Sagnac, a little boosty, or a little reduction gives them the speed of light they desired, speed of light that they need. So in reality, right, we're using applicable technology that's measuring distances, physical distances, accurately down to the nanometer, or I'm sorry, down to the millimeter. And it's using C plus or minus V. Not using any relativistic effects, transformations. They might start with a relativistic transformation somewhere, right? But then they'll drop first thing they'll do is they'll swoop up lab time, and then they'll drop the gamma terms. And so that's just that's just Sagnacking. All right. So I kind of gave the illustration earlier of what it looks like to be orthogonal to the position of the sun, but I had the sun in the wrong position to make it look coherent or whatever. But anyway, when you're in that position, you shouldn't be measuring C plus or minus V, right? So we'll read here what Hatch has to say to illustrate the VLBI problem. The idealized experimental setup is postulated. An idealized setup is postulated. One where the VL receiver is located at the equator at the precise longitude at 6 a.m. and where the Earth is at the winter solstice. And this means that the direction of the VLBI from the station to the center of the Earth is at the same direction as the orbital velocity vector. Our second VLBI station is located at the equator, but 100 degrees longitude away, i.e. 6 p.m. Both are observing the quasars in the direction opposite to the sun, i.e. it's orthogonal to its velocity vector in the geometry. The two stations are thus separated by the distance by Earth's diameter, and the fact is extended by common observation of the quasar is impossible because of Earth's rotation as part of this idealized assumption, and assumed by common observation is possible for this geometry. So he's trying to illustrate the problem that they're having and make it, nice and symmetrical and equidistant because they have a configuration here that they're doing it with. But he's saying, like, if we could have like an idealized scenario, we could really, really hone in and test that, right? But what they're measuring is a variance because he goes through the data from the VLBI and points this out for what they're measuring. So he's basing this on, he wants that idealized version of it so we could do it for symmetrical purposes and then get the, get a definitive answer. But that's not even necessary, right? There's things that exist like a phase conjugate mirror, right, which preserves the wavefront. It's a special mirror that reflects a wavefront in the way that it was received. Doesn't change it. So you could use that as a one-way measurement. You could set up an interferometer configuration to measure the variance in the speed of light in that way. And that's actually already been done. And that specifically shows that the wavefront has already changed. So how they were saying when you're in relative motion and the wavefront looks tilted a little bit or whatever, it's just C plus or minus V is just an illusion. Well, you can actually measure it like directly proportional to velocity every time using a phase conjugate interferometer. And that was done in the 80s, and Ruyong Wong wrote a review about it in the 2000s. And then, of course, back to this occurring on the winter solstice, right? Where we got the minimum, maximum dimensions of the so-called, period of the orbit, or the dimensions of the sun being furthest or closest to us. We make the comparison to Miller's data, who on the equinoxes made the same measurements, where the speed of light reaches minimum and maximum dimensions with respect to the east-west directions. All right, so the noon midnight problem is the same thing, right? So we have satellites going around the Earth, and they say that these satellites, due to general relativity and special relativity, because of their eccentric orbit, when they're perihelion and aphelion on their orbit, they're closest and furthest to the, with respect to the center of the Earth. That changes their gravitational potential, right? Because if you're closer to the Earth, you're gonna have a different gravitational potential than if you're at a higher altitude. It'll be lower. So they say that they make these corrections for this in the Earth frame, right? Okay, cool. So let's expand that out a little bit. And the sun and Earth is doing the same thing. They say that the Earth is going around the sun. The Earth has a gravitational field described by, the coefficients for Newtonian and or relativistic means in the general theory. So they got this field, right? Now, when your minimum and maximum dimensions to this field change, you should have to adjust these clocks in the same respect if you're doing it here on this much, much smaller scale with a much lower field, when we all know that the sun has the Big Daddy field, right? We all know Big Daddy field is out here, but there's no adjustments for that. This is a problem that is introduced in the theory that that isn't really talked about, and it isn't resolved. A couple of mathematical treatments have been given, but none of them actually give an explanation as to why this effect isn't observed if it's true, right? The sun can't be the cause of gravitational lensing, for Arthur Eddington's light experiment, if that gravitational field isn't also influencing the clock rates with respect to the position of the Earth on its orbit, where it's going to get, what is it, like 3 million or 5 million miles closer, plus or minus, when it's winter or summer. That's huge in the gradient. There has to be corrections. We're on the smallest scale possible. We're on oscillation rates that are 9,192 millionths of a second. Everything counts here. We're they have a special chamber that uses a magnetic field to adjust for ambient magnetic field of the Earth. Like, this is the fact that this isn't.
You got theodolites and plumb bombs being pulled off and veered on the surface of Earth by the mere existence of mountains.
All right.
Isn't that strange that vertical doesn't change with a 6 hour, 6 by 6 by 6 by 6 hour oscillation? Isn't that neat how vertical just seems to be just vertical all the time? But that same gravitational force is holding the Earth in orbit around the sun. Like, there's that much gravitational attraction between them, even at that distance away. But somehow, vertical is always just vertical, regardless of the rotation of the Earth. It's just, don't know where the sun is, but we know vertical is vertical. Just look at that plumb bob just doing absolutely nothing.
Dude, they get us every time with it, bro. They get us every time. But that concludes the presentation. And real quick, before we get into the wrap up, it is 9 p.m. So we are going to do the Aether Cosmology merch launch here. So I'll go over and review what all that looks like. I'm going to have a nice YouTube post here. Actually, do you one better. There's all right. So for a limited time only, right? We're doing this for 1 week. You can buy a membership subscription, a lifetime membership card, right? And what that gives you is $15. What that gives you is it gives you a biannual subscription to our newsletter, right? And you can also buy the Aether Cosmology hoodie, which I'll show you here in a second. But the newsletter will constitute the history of Aether Cosmology, the works that we've done so far, going over all the prezzies, all the subjects, getting it all in a nice detailed outline for you guys at the reading nights, etc. And updates on future projects, what we have coming up, and different, some upcoming experiments that we want to do, and how we plan to how we plan to achieve those goals. So all of that will be included in that. Now to start us off here, we have the Aether Cosmology shirt. And it's going to be hosted on the Ko-fi website. So you can go to mycoffee.com or ko.fi/spaceaudits, or you can follow the QR code. You can go there. The shop will be live there. I'll make it live here in a second after I finish this ad read. You can get the shirt there, and you could look at the back view and all that of it. We have the Aether Cosmology hat, Flex Fit hat. Here's Shane, little turtle, telling you that if your theory collapses, at least your hat won't. It's a badass turtle.
It's not a little turtle, yeah.
Right. So we got the Aether Cosmology hat. And of course, if you become a lifetime member, you can buy the lifetime member Aether Cosmology hoodie. It has the hoodie here, the Aether Cosmology logo here, lifetime member, and then on the back it has the toroidal field and Aether Cosmology on the back. And here's a little penguin Toby saying Aries' failure was in not wearing this hoodie. All right. So here's link to the shop. Be on the coffee.com/spaceaudits. Here's the hat. Oh yeah. So with the membership card, right, you'll get a digital copy of the card. It'll have your name and your unique member number that comes in chronological order when you make your order. So as the orders file in, you will get your corresponding member number. All right. Now for the discounts and other useful information that was written down in a scheduled post that should be live now. Well, that did not seem to go live. How do I just make it do it now? Anyway, we'll come back to that. I'll make it go live. All right, so discounts. This is super important here. So if you were subscribed to me on Ko-fi, you get a 15% discount. Now, the first 2 days of this sale, everybody gets a 15% discount. And then the next 2 days, it's 10% off. And then the last 2 days, it's 5% off. But remember, if you're subbed at any tier, you get 15% off. So my tiers start at $3. All right. And if you have sent me money on Cash App, you can send me a message and I'll send you a promo code where you can get your 15% off. All right. These are going to be made to order. So when the orders come in, we will get them shipped out between, we're looking at probably end of June, mid-July to get these shipped out. Did I miss anything on the release notes there? I'm asking the Aether Cosmology secretary.
All very good. All of the merchandise is limited time only. The lifetime memberships will stay up on the Ko-fi site for people to continue to purchase into the future to become lifetime members. But the merchandise we are having custom made, screen printed and embroidered. And so we will run the order for a limited amount of time, collect the orders, and then have our order produced. So
I get them shipped by June.
By June?
we
Probably not.
we should be able to start shipping the beginning of June, and just depends upon how many orders, how long it takes to get through all of them to be shipped out. So yes, the hope is to be able to have them back by the beginning of June and start being able to ship them out. And I think it's set up for US orders at the moment, right, Alan?
Yes.
And if anybody from outside of the US is interested in ordering, contact me and we can talk about international shipping, which I am not extremely familiar with, but willing to help. If you want to pay the international shipping, I will figure out how to do it. So contact me and we can possibly work out international shipping.
All right. Well, there you have it. All right. I will put a link in the comment section to the shop. I'll have all that set up, and I'm making the shop live now. So if you go to the coffee, it should be showing up in a few minutes. I'm gonna go
I like
ahead
how
and
Dayton Miller is our biggest supporter, dude. I didn't realize how down with Aether Cause Dayton Miller was. And look at all the boys who already have the Aether Cause merch. Doesn't that give everybody FOMO? Look how cool those guys are. Who doesn't want to be Dayton Miller, man?
Dude,
Also, I like how you're calling Kofi coffee, just straight up screwing, just coffee, calling it my coffee.
there's literally a coffee cup.
Yeah,
So-
but it's called Kofi, dude.
Yeah, it's not though. All right.
Coffee. All right.
It's definitely coffee. All right, so we got Ari here rocking the hoodie. He's an Aether Cosmology lifetime member, obviously.
You go, George.
Yeah, is that Mickelson and Morley rocking the Aether Cos hats?
Both of them, dude, together once again.
Dude, it's good to see them back in the lab together. You don't often see them together anymore, and it's great that they got together for this promo. Shout out to the boys. And then of course we have Maxwell. Shout out to the boys.
He looks crazy.
Yeah, he's really upset that everyone's misinterpreting his equations and removing the ether from them. He's like, guys, how do you explain the displacement current, which was explicitly derived off of a sea of vortices of rotating ether to facilitate that mechanistically? How are you going to remove the elasticity from my equations, which describe the elasticity of a medium to describe the flow of electric and magnetic currents? Why are you doing this to my why are you discontinuing my lines of force, says Maxwell.
Dude, that's probably why his face is so white and pasty and his body's so pale or whatever.
Yeah, he's just
beard. That beard is so high voltage lightning bolty shocky. You know what I mean? Looks like a Tesla experiment coming out of his chin.
That's where they got the character model for Heihachi from. Just Maxwell.
Dude, that beard has seen some stuff. All right. So that concludes Aether Cosmology Roundtable number 82. If there's any questions on the Prezi or merch, if not, we'll go ahead and wrap it up.
Nope.
All right, lads, commencing the wrap.